It's really a pleasure to be here today to talk about open source messaging, specifically how messaging has really evolved over the last, I'd say, 40, 50 years. Messaging started off as a very simple communications infrastructure, but it has changed and it adapted to many different forms over the last 20, 30, 40 years, all the way back to things like ARPANET. But one of the things that I thought was really interesting, speaking of toys, is that, I always have felt that there was this one common thing that occurred within messaging that always took me back to my childhood. And the toy that kept popping back up into my head was this toy that I had. It was a little block. You can see it on the screen here that was built to basically allow for kids to figure out spatial orientation. It had all of these different sizes, it had all of these different pieces, and the whole goal of the toy was for a young child in preschool, which my wife's a preschool teacher, so I get lots of stories about things like this. Look at the different blocks and they figure out how those blocks can fit into the appropriate holes to get the blocks inside of the bigger block. And I look at the lessons that we learned from that early on. And one of the things that I think stands out is that there are so many things that we can learn from something so simple. The first being that, it's really, really hard to fit a square peg into a round hole. The whole purpose and design of the toy was to teach kids that there are appropriate sizes and shapes, and there's appropriate ways to get things into the toy, and that they needed to recognize the patterns that were there for the ability to get that piece into the toy. The other thing that we learned very early on, and again, as my wife will attest as a preschool teacher, is that sometimes having so many options can become frustrating. If this toy was simply designed to do one thing or had two pieces, it would be a lot easier. But when there are more pieces involved, children get frustrated easier because they can't figure out what piece goes into what hole, and it takes them longer to figure those different things out. The other piece that really comes into play is that there's always a solution. There's always a piece that's usually sitting right in front of you, but that piece is not necessarily as clear as you might think. And that's kind of where I think we've gotten in messaging as well. We have so many different options now available to us for digital communications. Long ago it was we were building our own sockets using, the sockets APIs, whether it was in Linux or WinSockets. And then messaging came along to abstract and normalize that. And we had proprietary solutions, and then we had specifications. And what we've started to get into this habit of is just trying to force ourselves into a solution that doesn't necessarily meet the requirements that we have for our business. And that's really the last point that we get to with our example of our toy, which is that forcing something typically ended up meaning that the toy was broken. I can say that as a child, at one point or another, I usually had found some hammer-like device to pound a piece into the toy, which never ended well. But that's really the key to what we're seeing in the space of messaging, especially in open source messaging. If you go and look at all of the different options that are available to us for digital communications, it's becoming very difficult to kind of look at what are we have available for us to make these decisions, whether it's AMQP or MQTT as specifications. You have JMS, you have things like Kafka and Pulsar. You have solutions in the open source market like RabbitMQ or Eclipse Mosquito, and all of them do different things and different things well. And that doesn't even touch on some of the proprietary solutions that are available from like TIBCO, which is like TIBCO FTL and EMS, or other proprietary solutions that are very proven and true solutions to solving some of these problems like IBM MQ and many others. The real key is that what we really need to focus on when we have that many options is really focusing on that aspect of what are the requirements that we're trying to achieve. And interestingly enough, if you look at the requirements, sometimes looking at all those requirements actually makes the decision harder because it's hard to prioritize one thing over the other. If you look at some of the requirements that are coming out for open source messaging and messaging in general today, it really comes down to things like real time. We need the ability to send and receive communication in real time so that applications can make decisions and drive event processing with the knowledge that's at hand right now, not 3 seconds, 5 seconds, or 10 seconds later. We need things that are designed to manage high throughput, which is high volume. So if you look at like the IoT side of things, taking a temperature sensor is one thing. Taking interactive sensors from a vehicle that's moving in real time is another. You have significantly more volume of data depending on the business case that you're trying to solve. And on the same token, low latency becomes a key proponent. Again, being able to make a decision in a second's time is relevant for something like a decision, say, to directing a package on a logistics line. Making a decision in a second might not be acceptable in a situation where I have to make a split second decision on whether or not that car is in the path of a pedestrian or not. So you need the ability to leverage multiple different aspects of a messaging solution. Things like persistence, multi-site locations, multi-tenancy, different acknowledgement models. They all play a significant role in how we choose the right solution for data distribution. Now, with all these different requirements, we also have all of these different applications to messaging as well. Long ago, it was an easy solution. We were building solutions in data centers or on systems that were in our control. But now we have a wide range and a plethora of options with regards to deployment patterns, whether they're cloud, on-premise, or a hybrid model where we're using private and public cloud for our data distribution, or if we're building things for integration services or stream processing or streaming analytics or event-driven architectures. They all have different aspects of what is needed for a communications infrastructure. And there is a lot of overlap, but sometimes those pieces that overlap might not necessarily fit as well into that round hole, and we start to force that square peg into that round hole again. So, what does it come down to? What is the best solution for a given application? And I'd love to say that, there is this one size fits all, but there really isn't. No one thing fits perfectly. If any of you have ever bought a one size fits all type of piece of clothing, the one thing you will realize very quickly is that one size doesn't really fit all. It typically fits none other than the one person that it was made for. And that's what we're kind of starting to see is this approach and mentality of shoehorning messaging communications into this one size fits all really is starting to handcuff us in the ability to really service the business needs and the applications that are available. We have a lot of solutions that are available in the open source community for messaging and data distribution that are purpose built for different applications. A great example of that is if you go and look at Eclipse Mosquito. Eclipse Mosquito is built and designed for one thing and one thing only. It's built and designed to be an MQTT broker. And because of that, it allows for that solution to meet the demands of a lot of the IoT types of functionality that many customers need. I think that there's this mentality and has been and I would say it's not just in the open source messaging community, it's across all of the messaging community of this nirvana for that solution that meets all of the different demands. But when you really start looking at all of the different requirements, it becomes extremely difficult to meet all of the specific requirements for every specific application implementation. And that's really what I think has started some of these debates in the open source community around Kafka versus Pulsar. There is no denying that Apache Kafka is and has been a de facto standard for stream processing and building streaming types of applications. And it is extremely well used and extremely well deployed across a large set of users within the community. Kafka is built and designed from the open source mentality. It's built and designed to provide that fully distributed logging mentality. And it's built and designed to meet that specific requirement of providing kind of that distributed communications infrastructure that was built for a messaging layer for things like distributed logging. But it has grown so far beyond what it originally was designed for. One of the interesting conversations I remember having with one of our principal architects and engineers a long time ago with one of our own products was a customer was doing something with one of our products, TIBCO Rendezvous, and I remember distinctly the engineer saying, "Well, we never designed it to do that." Uh, and and I remember having the conversation of, well, you didn't design it to do that, but the customer is doing that with that solution, and they're being successful. And that's one of the great things about innovation is that things like Kafka, which are originally designed for a very specific purpose within something like LinkedIn, have grown to allow for clients to build very complex streaming solutions and allow them to build very complex stream processing engines into their application code for data distribution and for things like streaming analytics. But like I said, as that's grown, I think there's been a lot of challenges that have been put forth with regards to expanding and scaling Kafka to what we would classify as an enterprise level type of model, where you have multiple different applications trying to access data at the same time. Or if you're trying to deploy data not just within a single data center or within a single cloud zone, but you need to distribute that data in a geo-replicated type of approach across multiple different regions, whether they're North America, Europe, and Asia, or within different geographical zones within a cloud provider. Those become, they're functional, but they become more of a challenge with something like Kafka. Whereas Pulsar has really been designed and built for that different approach. They've taken that mentality of starting from the enterprise communications infrastructure level and the large scale and allowing for a significant portion of the product to be built around the ability to send and receive data and manage that on a global scale across multiple different users within a enterprise ecosystem. And that's really where I think the two solutions differ greatly is in the approach to the design. As I said, neither one of those approaches is wrong. Neither one of those approaches is what I would classify better or worse. It really comes down to the application that is being used and what is the application's design and what are the needs for that given application. Apache Kafka has a lot of strengths. And it has some weaknesses. Just like Pulsar and all of the other solutions, they all have the areas where they've been built and designed and exceed expectations, and other areas where they tend to be less performant. So a great example is this Kafka, again, being designed from that ground up distributed logging type of mentality. What Kafka provides is a very large community that has a lot of users that are available to answer questions. And more importantly, it allows for a lot of control over the actual distribution of data and, more importantly, the processing of that data. Kafka is built and designed really as that developer tool. It's designed to be that messaging communications infrastructure piece that sits in your toolkit that allows you to leverage digital communications and then, more importantly, take that and leverage that to make decisions within your application space. So stream processing and all of the pieces that are built around things like accessing data are all functions that have been pushed out to the client. Whether those are server process clients that have been built to handle things like K-tables, or if they're just application clients using the Kafka Streams API or the Pub Sub APIs, the clients are the ones that do the work for managing and processing that data. Whereas Pulsar has, again, taken a more of a different approach where it definitely allows for those types of applications where you can build a more traditional application that's building solutions to meet those demands. But where it really comes into play is this aspect that Pulsar has built again from that enterprise ecosystem, the model for allowing for a global managed multi-tenant type of solution that can be extended to allow for more functionality to be pressed into the actual infrastructure. One of the most powerful things within Apache Pulsar is this concept of Pulsar Functions that allow you to take your stream processing code, the code that you would build into your application or into your streaming engine, or a great example I can give you is this, which would traditionally be built with something like our TIBCO Flogo process and run as a separate process outside of the messaging infrastructure, that can now actually be embedded as part of the Pulsar broker ecosystem and run in line with the actual brokers themselves. And actually, we have some open source tools that are already available out there that allow you to take Flogo and deploy it into a Pulsar broker. And so you can take your Flogo code, and now instead of having to run this as a separate process outside of the messaging infrastructure, it can run in line with the actual processing. So, for example, I need to take a flow of data in. I want to look at that data, make some decisions on that data, and then transform that data and then output that data to a separate topic. Previously, that would be some type of external loop that would occur outside of the messaging ecosystem. But now Pulsar with Pulsar Functions can deploy that kind of like serverless code into the Pulsar brokers and allow for that to happen in line. The other area that I think that Pulsar has really started to move forward and is becoming a real viable solution on the marketplace is in the announcement to allow for Kafka-based applications to access Pulsar without having to change a single line of code. So now with Kafka on Pulsar, or KOP, you now have the ability to take your Kafka-based applications, whether they're large-scale integration solutions or they're solutions that have been built to use the Kafka APIs, as long as they're speaking the Kafka protocol, they can actually connect to Pulsar brokers, and to the application, it just looks like a Kafka node. And that allows for some significant power in allowing for Kafka-based implementations to continue to leverage Kafka for their application ecosystem. But if there is a need to expand that to global geo-replication or the ability to provide some levels of multi-tenancy, you can do that now with Pulsar and Kafka together. And that's really the key, going back to this concept of, one size fits all, doesn't fit all, is that we need an approach that allows us to be more flexible and use the appropriate solutions for the given tasks at hand. So, one other area I do want to highlight, though, is this aspect of IoT. A lot of people are using Kafka and Pulsar for things like IoT implementations and building MQTT proxies into Kafka and Pulsar. And those are great solutions, but one of our approaches is to take the model of, again, using the right tool for the job, and so leveraging something like Eclipse Mosquito, which is built and designed specifically for Apache Pulsar, or for IoT rather, and allowing for a MQTT based implementation to then natively integrate with things like Kafka and Pulsar is really the key. And I think probably the best way to highlight this is I'm going to kind of skip to the end here and talk a little bit about a very simple demo that I think highlights how some of the power that can be harnessed from Pulsar, Mosquito, MQTT, and all of these different solutions coming together. So one of the things I'm going to show you here is a demo that actually, this is running in my house. So one of the reasons I'm presenting a little differently here is because I want to be able to show you some real-time functionality of some things that are happening with Pulsar and with MQTT, and then ultimately could be pushed into Kafka, and I'll talk a little bit more about that. So I'm going to cut to a couple of different views here. So different camera. I'm basically set up here in my office, and what I have set up is if we go back to that slide, you can see that what I'm going to demonstrate for you is a automated control system that's built around a MQTT enabled door lock. So this door lock is actually installed downstairs on my garage door. My kids and my family are actually supposed to be getting home from school here soon, so hopefully I will beat them to the punch and either lock them out or, more importantly, not lock them out. But this whole setup has been built on TIBCO's cloud messaging infrastructure. And what that is doing is that it allows me to use Pulsar as the publishing engine to send signals to that MQTT lock to either unlock or lock the door at any point in time. So again, being able to take Pulsar commands and use those commands to enable a communications infrastructure that will reach not just from my local house, but use TIBCO's cloud messaging so that I can invoke these anywhere, anytime. So let's go ahead and take a quick look. So if you take a look, this is downstairs in my garage. This is my garage door, and you'll notice that there's a light that's been installed next to the door that's green currently. Now that light is actually tied into, again, the whole system, and we're going to use Pulsar commands and MQTT commands to send signals to the door to lock or unlock. So if I send the lock command, which is actually running on a Raspberry Pi, in my remote office, actually. It's actually not even on site here with me. You should see that the light will then turn orange. And you should, if you watch the lock, you'll see the lock will actually awaken. It'll get the signal to lock the door. And then once the door command is actually tripped and triggered, the light now turns red. So again, with one command that I've issued from a Raspberry Pi, I can now send and manage multiple different scenarios and use some of the commands for Pulsar Functions to control things like also signaling a hue light that changes colors and things like that. Before we go too far, I definitely want to make sure I send the unlock command so that when my kids and my family get home, they are able to get into the door. They would not be happy with me if I didn't do that. But so you can see, again, an unlock command issues that similar process. The light turns orange, and once the door is unlocked, now that signals the light to turn green. And this is all tied into a number of different things that allow for us to control those different components using open source messaging, Pulsar and MQTT. I could have just as easily leveraged something like Kafka here. But one of the reasons I chose Pulsar was because of this fact of those Pulsar functions I talked about earlier. Because where a logical extension to this comes into play is, what if I wanted to do something like two-phase authentication? What if I wanted to validate that the lock or unlock command was actually coming from a device that I wanted to trust? And with Pulsar functions, you could easily capture that lock command within the Pulsar broker, issue those commands to say, I want to send a text message to a mobile phone number with a passcode, and have the Pulsar brokers wait for a response coming back from the user to give that passcode, so that you know that there's a two-phased approach to that, so that only the lock and unlock command is coming from an authenticated source. And so that's really where the power of what I looked at Pulsar was this ability to extend and leverage this communications infrastructure as more of a server functionality, where I can leverage things like functions to do inline stream processing.